In this video, we're going to complete task 5. And in task 5, we're calculating the incremental costs and the incremental QALYs for treatment B versus treatment A. So if you recall, in the previous task, we were working on the discounting sheet and we were discounting the aggregated costs for treatment A, and then the aggregated we discounted the aggregated cost for treatment B. We discounted the aggregated QALYs for treatment A and the aggregated QALYs for treatment B. And so what we can now do is compare the discounted aggregated costs for treatment B against the discounted aggregated costs for treatment A. That's a bit of a mouthful. We're going to just refer to that as the incremental costs from now on. And we can do the same with the QALYs, the discounted aggregated QALYs for treatment B minus the discounted aggregated QALYs for treatment A. We're just going to call that the incremental QALYs. And this is a very important step along our journey to evaluate the value of treatment B. How much extra does it cost? Taking into account time preference through discounting. How much extra does it cost? How many extra QALYs does it give us? And so there is a new sheet that has appeared called incremental outputs. And the first step of this task, so step 5.1, is to calculate the incremental costs for each cycle. And this is somewhat simple. It's simpler than what we were doing in the previous step. So what we need to do is start off with an equals, and we just need to take the costs for treatment B and subtract the costs for treatment A in each cycle. So we're going to go to the discounting sheet, and we're going to look for the cost for treatment A. Sorry, I just made a mistake there. So we do equals discounting. Where's our discounted cost for treatment B in cycle 1? It's this one here. And we're going to subtract the discounted aggregated cost for treatment A in cycle 1. I'm going to press enter. So $1,000 exactly, which is what we would expect because treatment B costs $1,000 more than treatment A. And in cycle 1, treatment B has not had a chance yet to have an impact on how patients move between the different states. So it's not surprising that it's exactly $1,000 extra. It's also not discounted in cycle 1, so that's why it's exactly $1,000. So that was correct. It liked that. And just like in previous steps, there's a hide columns button, which I'm going to use. And the next step here is 5.2, derive the total incremental costs. And there's two approaches. I'm going to let you read that paragraph there under hint, but there are two distinct approaches for doing this. So one of those approaches is somewhat more difficult, which is we will apply that half cycle correction to all of these incremental costs. All right. So remember what we were doing in the previous task. You have to take the sum of, well, it depends on what the time horizon is. Take the sum of those costs and then subtract half of the first cycle and then add on half of the next cycle. So we could do that. And if we were to do that, what I would do personally is go to the discounting sheet and I would find one we've already done, like this one here. I would copy it and then I'd go to the incremental outputs and I would just paste the formula in there. And that should work, right? Because that's going to be referencing these cells. That should work. It says it's correct. And it's opened up the rest of the sheet. We now need to do the incremental QALYs. But I'll show you the other approach for the incremental QALYs. So for QALYs, what do we need? We need to take we need to do an equals, go back to the discounting sheet, pull in the discounted aggregated QALYs for treatment B in cycle 1, that's this one, and then subtract the same thing but for treatment A, which is this one here. So on the discounting sheet, we want GK34 minus DZ34. And that's going to be exactly 0 in cycle 1 because, again, it's a Markov model. So during cycle 1, no one's moving until the end of cycle 1. So treatment B does not have any impact until cycle 2, where it starts to provide some incremental QALY gains because it reduces the probability of moving to a worse state compared to treatment A. So you can see we have all of this. I'm going to just tick that box to say hide columns. Okay, and then what we need to do is calculate the total here. And what I'm going to do is a slightly different approach. We don't have to do that half cycle correction. We can if we want, we don't have to. What we can do is just take this formula, copy it, and just paste it in the total. And why does that work? Because instead of it referencing, IS34 minus GH, which is going to be, let's find it, IS34 is this one here, minus GH is this one here. Instead of doing that, when I copy it across one, it's going to be taking this total, which accounts for a half cycle correction, and it's going to subtract this total, which also accounts for a half cycle correction. So I can just take this formula, copy it, go into here and paste it. Really, really simple formula. And that actually accounts for a half cycle correction because it's already been dealt with on the discounting sheet. And so I've illustrated both of those different approaches here. Either do the half cycle correction on the values here, or just reference the totals from the discounting sheet. I think that's a bit more elegant, to be honest. It's a bit simpler, that sort of formula, as opposed to this sort of formula. But both of them work. And that's the end of task 5. The next task will be calculating incremental net monetary benefit, and we'll do that in the next video. I'll see you there.